Welcome once again to our Oxford Brain Diagnostics guest speaker series. By way of introduction to our company, Oxford Brain Diagnostics, we're an Oxford University spin-out with a method for analysing brain MRI based on cellular structures. And we're working towards a clinical tool for early detection of Alzheimer's disease and other neurodegenerative diseases, which we want to be used by clinical services all over the world and drug developers as well in their efforts. So that's a bit about us, and now I'm very pleased to introduce Professor Takeshi Iwatsubo as our guest speaker today. He's a medical doctor and one of the leading dementia researchers in the world, and has many titles, I think. You're chairman of the Japan Society for Dementia Research, a director of the National Center of Neurology and Psychiatry Neurological Research Institute, principal investigator for the Japanese ADNI project, PI for the J-TRAC project as well, to establish a trial ready cohort in Japan, and throughout all of that, you are currently professor in the Department of Neuropathology, which is a specialty very close to my heart because I spent many years in a neuropathology lab doing my research in Oxford University, but you're professor at the Graduate School of Medicine in the University of Tokyo. So we're honoured to have you join us today, and very much look forward to your presentation about your work in this field. Thank you very much.
Okay, thank you very much. So I'm quite excited that I have this opportunity to talk about our relatively clinical activity we have been doing these 15 or 20 years. Okay, so I may not need any introduction about the ADNI activities. So you may remember that Mike Weiner and other US experts started this activity back in 2003 or 2004. So we have had about the launch of the North American US ADNI, and we, all of us, were convinced that we have to start very similar structured study in Japan as soon as possible. However, we have been very late. So in Europe, a couple different traditional imaging and studies have been ongoing, and then in Australia, Chris Rowe and Colin Masters and the active researchers were starting to convert some of the ABLE activity to the PET or imaging based studies. And last in 2007, 2008, that we have launched the Japanese version of the ADNI activity. And then you may know that a couple other countries here in Asia have been very much interested in going to ADNI, but it was very tough for them to perfectly replicate the core part of the ADNI activity. So as I will show you later, we, as a very late comer, we have been concerned to how we could replicate the very important details or protocols of the ADNI activities. So this is not a Japanese PPS3 partners. This is a US version, and this is not the founding size of Japanese. So this is from the US ADNI, and then I have very recently had from Mike Weiner that ADNI 4 was approved, and then as they are studying this fourth version starting from August 1st. So this is a summary slide of the Japanese ADNI. So this was the first longitudinal observational study for the imaging biomarkers and fluid biomarkers, and inside for the surrogate marker for the focusing initially on the MCI stage of Alzheimer's. And then as I have emphasized that we made so much emphasis on using an nearly identical protocol to the North American, and the initial focus was, of course, the late MCI phase of Alzheimer's disease. So initially, we started this as a 5-year study, but we needed 7 years to complete the initial part. And then last that we have recruited 38 clinical sites mapped here. So we have covered virtually all of the high-level clinical study sites on Alzheimer's in Japan. And the initial goal was 600 subjects. And you may remember that US-ADNI 1 had a goal of 800. So at first we thought that the maximum for our capacity may be 400 or like that, but we consulted this with statisticians, and we realized that 400 is too small. So now we have raised the initial goal to 600, and then last that we were able to fully enroll the 537 individuals, almost 90% of the initial goal. And that we have in the J-ADNI first stage, MRI covered structure pattern, not including the DTI or functional or ASL. And then most of the MRI images, structural images, obtained by 1.5 Tesla massing, but there are some included 3 Tesla, and the standard one was 3D MPRH. And then for PET, so the beauty of the J-ADNI first stage was wide coverage by FDG PET. So at the end of the project, we have covered 63% of the whole visit by FDG. And this was the first experience for us to conduct multi-site nationwide amyloid PET imaging study. And then amyloid PIB, Pittsburgh compound B imaging covered 35% of the total sites. And then 2 sites, Tohoku and National Longevity, used the Japanese homemade, very classical amyloid from BF227. But you may know that this is not with optimal performance. So we are now using the PIB data for the reference. And then we got blood and ApoE in 100% of the individuals. And then we have obtained cerebrospinal fluid from 35 to 40% from each of the very mild AD or MCI, or even the normal cognitive normal individuals. So this was very revolutionary for us in the history of Japanese clinical research. And last but not least is the standardization effort for the clinical or cognitive measures. So when we have made a Japanese translation version of the so-called uniform data set of the NIA. So talking about the funding, so all 3 major public funders from Japanese government were interested in supporting us, and then especially the Ministry of Industry, not the Ministry of Health and Welfare, were very much enthusiastic about supporting us. And then as a peak of the project, we obtained about $4 million US equivalent per year. And the percentage coming from public and private was 2:1. So this is very similar to the US size. And then following the US public-private partnership style, we have organized 2 industrial scientific advisory board. So there is open innovative assembly of the companies, and imaging company I have included 7 international and domestic companies, and the pharma I have included 11 major drug makers. So this was the first public-private partnership in such a pre-competitive setting with us in Japan. And I'd like to tell you that the J-ADNI database was released fully for the research use from the National Bioscience Database Center. This is a governmental database center back in 2016. And then anyone in and outside Japan, regardless of the academic or industrial research use, anyone can have access to the NBDC and obtain the full data set that including the whole imaging data. And then, so I can tell you the total number, approximate number of the data sets. We have 2,500 MRI structural images and more than 1,000 FDG, 600 amyloid PET images. And now we are working on the blood test, collaborating with the Shimazu group on the blood plasma and beta composite scores. So this slide shows the progress of the recruitment in J-ADNI, and so I have shown the how long that we have taken to recruit the initial 50 enrollment in the cognitive normal and amnestic MCI and the mild AD groups. And as you see here, we were very surprised, but I'm very lucky to see that the cognitive normal elderly individuals were very much interested in this type of project, and initially they rushed to the clinical sites. And the major target was the late amnestic MCI, and it took some more time to recruit a whole number of mild AD advanced control individuals. But by the end of March 2014, we have enrolled 537. So I will first show you the amyloid biomarker data. So this is a PIB PET quantitative data in each group, and we have Professor Kenji Ishii from the Tokyo Metropolitan Geriatric Hospital, and he has been the leader in amyloid PET imaging standardization and analysis. And as you see here, he has calculated the SUVR in each group, and as you see, mild AD individuals that initially diagnosed clinically as mild AD had amyloid. Not more than 90% were correctly diagnosed. And in the MCI group, the amyloid positivity was about 65%, and this is very, very similar to the positive ratio in US-ADNI and also ABU. So this is very natural. Even in amnestic MCI group, the early correct background pathology diagnosis may be very difficult. And then we have seen that more than 20% of the control cognitive normal individuals already had amyloid positivity. So this was our first experience to see the preclinical Alzheimer's disease population in the multi-center study setting. And then we had seen the very nice correlation with E4 genotype was amyloid elevation. And then we had 83 cases who donated CSF together with PISPA compound B amyloid imaging. And as you see here, this pattern is very similar across different nations. So in amyloid PET positive individuals, we had seen the lower beta 42 values, and then in the amyloid negative groups, beta CSF beta 142 was normal. So this corresponded very well in the Japanese population as well. So this is a bit busy, complicated slide, but we have tried to compare the baseline data of J-ADNI and North American ADNI cases with amyloid information. That is, the individuals had either amyloid PET or CSF testing, and then or diagnosis as having positive amyloid or negative amyloid. So you can see that the length of education, duration of education is somewhat different between US ADNI and J-ADNI. So J-ADNI participant had a very standard level of education, but as you know very well, US ADNI participants are very highly educated. And the gender ratio. So we had a very balanced level of male-female ratio, but in US ADNI, especially in the main MCI group, male, highly educated male population, white male population is a bit predominant. And then you know very well that ApoE4 prevalence is different between Caucasian and Asian population, and as expected, we had a slightly lower ApoE4 ratio, and even though the standard ApoE4 positivity ratio in the general population here in Japan is a bit lower, 20%, compared to the 25% a bit more in Caucasian. But in the J-ADNI population, it is slightly overrepresented, and probably because some of the normal group participants might have been relatives of the amyloid positive MCI or AD individuals. Yeah, and then this slight difference is seen also in MCI population and also in AD population. So in US ADNI, 68% of the AD participants were E4 positive. So this is very close to the data usually seen in clinical trials. And then in Japan, 59% was positive. So this is slightly lower than Caucasian, but we were quite surprised to see this high ratio of E4. And then another minor but interesting point is that in the ADNI cohort, the mild AD dementia does not mean CDR1. Yeah? So CDR 0.5 population can be clinically diagnosed as having slight dementia. Yeah. So you can see that in US ADNI, the CDR 0.5 and CDR 1.0 ratio is almost equal in the mild AD dementia population. But look at this. In Japan, CDR 0.5 predominates over the CDR1 population in AD. So this is quite interesting, but as you will see in later data, Japanese mild AD population recruited in J-ADNI have been a bit milder compared to the those recruited in the US ADNI. So, and this was very somewhat close to the conversion point from MCI to dementia stage. And then, what about the amyloid positivity? So in the cognitive normal population, so in Japanese, this was very similar to the PIB positivity rate, but this is quite a higher than expected in US ADNI population, a bit more overrepresented in the cognitive normal population. So there may be some positivity bias as over recruitment of amyloid positive volunteers in US at some area stages. So this is one of the major clinical endpoints, the MCI to dementia conversion rate. So from here, green shows the J-ADNI data, and the blue shows the US data. So as you see, the conversion from MCI to dementia stage progresses slightly faster in J-ADNI compared to the US ADNI. But it is quite interesting that at the 3-year stage, the US ADNI catches up. So the interpretation may be difficult, but J-ADNI participants may be a bit progressed compared to US MCI. So in the MCI population, they may be a bit closer to the conversion point. So they convert a bit rapidly. So in amyloid positive MCI population, prodromal AD, that trend is almost similar. Yeah. So as you may remember, about 60% of the MCI individuals who had PIP scan had a positive amyloid. So including those who didn't have any amyloid assessment, the ratio, total ratio, MCI, among the total MCI population, the amyloid positivity ratio may be very similar. So this is one of the representative data from the J-ADNI compared to the US data. So now we have compared the progression pattern of MMSE, ADAS-Cog, serial sum of box, and FAQ between US and J-ADNI. So I've shown the MCI and the mild AD data in composite slides, and that roughly speaking, the progression in MCI was very, very similar. Yeah, but strictly speaking, J-ADNI participants were slightly faster in some of the aspects. But we have seen that there is a striking similarity between in the MCI due to AD population between Japanese and Caucasian population. But there is an interesting discrepancy in the mild AD population. So apparently, US ADNI participant had worse baseline score and then progress a bit rapidly. So this may be due to the mildness of J-ADNI population compared with the ADNI mild AD population. So my interpretation is that in United States, mild AD population had been recruited using the full range of the inclusion criteria, including slightly worse patient. But in J-ADNI, the participants were a bit more clustered close to the conversion point. So that may be the real reason for this slight discrepancy in mild AD population. So, so you have made a very important question to my drafted slides. So what happened was the J-ADNI second stage, which was renamed to the AMED, the preclinical Alzheimer's disease studies. So, so this is a summary of this intercalated project. So the J-ADNI 2 was headed by other researchers in Osaka for some reasons. So, and then I have planned all this J-ADNI 2 stage, and the bottom line is that we have shifted the major focus from MCI to preclinical AD. So in this group, we aim to use the early and late MCI population as advanced positive controls. Yeah. And the major focus was the preclinical AD population. And then this project started in 2015 and ended at 19. And in this project, we have followed the US ADNI 2 MCI protocol and aim to include one of the three functional modes, including resting fMRI or arterial speed leveling or diffusion tensor. Yeah, but very unfortunately, this study didn't recruit so well, and then spending now 5 years, they have recruited only 38 cases, including all the spectrum of the early stages. So I have pasted the NBDC human database description, and then you can find the MRI quality control procedure document here, including the DTIs. And then very recently, our PET researcher, Professor Michio Sanda of Kobe, have written up a paper on this J-ADNI AMED preclinical study, focusing on the PET part and then some of the CSF biomarkers. So this is a very, very small study, and it's a regret that we couldn't assist the Osaka City team to do a bit better. But the total size of the MRI data set is too small to draw some conclusion. So now is the time for the prevention trials in preclinical Alzheimer's disease. And now in Japan, the A4 study and upcoming AHEAD studies are ongoing. So you may know that A4 has been led by Professor Risu Sparling since 2014. So this is a preclinical AD trial using solanezumab of Eli Lilly as a test drug. And the screening is a very, very huge size screen by for beta pill. And then they have done screening for 4,500 PET screening and recruited 1,200 amyloid positives and randomize them. And then we will be having the 4.5-year endpoint data next year. So we were scarcely losing the opportunity to join the A4 study. So my initial plan on the J-ADNI 2 AMED preclinical study was to devote some restricted proportion of the observational study to convert them to and merge them to the A4 study, but it was unsuccessful. So our University of Tokyo site joined as last formal participating site out of the 67 international, mostly American sites, and we are following up. We have screened 161, scanned 100 individuals, and recruited 20 amyloid positive. And I remember 14 or 15 were now completing the 4.5-year follow-up. So this is an incredibly long clinical trial. And 2 years ago now, we have started the A4-5 and A3 study, collectively named AHEAD, together with the ASI folks. And as you know, American LCTC has chosen the lecanemab as a test drug for the AHEAD study. So the next serious problem was how could we efficiently recruit the preclinical Alzheimer participant who remain asymptomatic? So the answer is we may need the trial ready cohort both for clinical trials and as an observational study following up the ADNI style. So this is the American trackpad. So they have the feeder, and inside the trackpad they have the APT web study that is very closely connected to the in-person trial ready cohort and trackpad studies. And you know that so European researcher had a very fantastic structure for the EPAD, but we have had that IMI has quit the funding for the original EPAD. So now the EPAD population is trying very hard to collaborate with a pharma company or the gap researchers in the United States. So now we have chosen to adopt the American trackpad style studies because we have compared the details of a couple different trial ready cohort, and we came to the conclusion that based on the A4 experience, it was very natural to adopt the ATRI style format and way of clinical studies. So this is the reason why we have a relatively small proportion of data from the advanced MRI technique right now. So we are maybe now focusing a bit too much on the molecular imaging or molecular fluid biomarkers. So this is the structure of J-TRAC. So we recruit the elder individuals through internet. So this is very challenging, but we are managing to do so. This is very similar to the APT web study in United States, and we obtain the demographics and basic information, and conduct two cognitive assessment using Cogstate and CFI. So we are now trying very hard to contact different sources of elderly individuals from existing registries or calling to public by media report. And then tentative goal is 15,000. So we have been using some basic risk algorithm. So I have included this. And the second part is J-TRAC on-site study. So this is very similar to the trackpad in-person study in United States. So that we conduct selected cognitive tests, especially the PAC components, MMSE, logical memory, FCSRT, and the disease symbol to conduct a standardized assessment, cognitive assessment of the preclinical AD. And then we have the blood. So we gave up to collect the CSF, so we only had blood. But then we are studying the plasma assessment, and we have decided to include all the participants by either of the two major amyloid PET reagents, that is AMED for beta pill or Besamil flutamidamol. And the amyloid elevated individuals will be followed up or introduced to the clinical trials. And then now we have started to conduct a tau PET sub-study, and then I may have included some of the initial slides here. So this is a progress in the J-TRAC web and in-person study. So we have started the web study back in fall of 2019, just before the pandemic. So this purple line shows the cumulative number. So Japanese elderly population so much interested, and there was a very rapid recruitment, but now we had some very stable stages because of the COVID pandemic here in Japan. But very recently, major Japanese media like national broadcasting or major newspaper have reported the progress of the J-TRAC, and that they have such a very, very big impact. So the J-TRAC on-site study was started half a year later, back in 2020, just as a beginning stages of COVID here. But 7 clinical sites have worked very hard, and then now we have recruited 414. And among these, 94 individuals were judged as having elevated amyloid level, including the slightly increased level judged from the centiloid score. So this is a design of a J-TRAC web study, so that we have translated and then redesigned the front page, and that we have the CFI and COG state, the Japanese version, and it's working quite well. So this slide shows that we are now starting to work on the machine learning for the prediction of amyloid risk. And then this is our initial effort when we didn't have any of our own data on the on-site study. So we use the A4 screen data as a teacher data or standard data, reference data. And then we have tried to predict the amyloid positivity on the J-TRAC web study participant. And then this is a summary. So the top 3 predictors or age. So this is very natural. And then the second one was CFI. So this is a cognitive measure, but probably CFI asks your cognitive function is different or lowering compared to 1 year ago. So this represents a progression. So this may be the one is the power of the CFI. And then a third one is a family history. So apparently ApoE4 positivity may be related. So this may be the last slide summary. So starting from the J-ADNI activities, so it took so many years for the data collection, data analysis, and the primary paper in Alzheimer dementia was published in 2018. We were able to establish the infrastructure for these modified trials based on a non-competitive public-private partnership setting. But global, the emerging global clinical trials also here in Japan almost urged us to switch from this type of a pure academic study to the trial ready cohort. And then, as I have shown you, we have discussed very, very actively, and then initially chosen the track pen type trial ready cohort. And then now we are starting the enrollment of some of the participants to the upcoming AHEAD. And this summer we will join the Trailblazer ALZ3 of Eli Lilly. And then another aspect is that we are starting to collect some financial compensation for the recruitment of optimal participant on a contract basis between the University of Tokyo and individual farmers to make all the process very transparent and to avoid the conflict of interest. And so this is our hope that successful outcomes of upcoming anti-AMED phase 3 trials like those of lecanemab or donanemab will fuel the enthusiasm on these modified trials, including enthusiasm on the imaging research and imaging diagnostics here in Japan. And the last point is a bit different, but you may know that we have a universal public insurance. That is not fully or totally covered, but basically everyone has coverage by universal public insurance. So the diagnostics or medicine used here in Japan depends very highly on this public insurance. So the coverage may determine everything. So it may influence the use of DMTs and imaging biomarkers in Japan. So we may have to know this. Yeah. Okay. So that's all. So this is a member of our basic neuropathology laboratory with us. So here is a very old building of University of Tokyo Hospital, but we have a new building over there, and we have the phase 1 or clinical trial, clinical study ward focusing on the dementia and CNS disorders, and CNS clinical studies are driven by the experts from the early and exploratory development part of the University of Tokyo. So this is a very, very fantastic cherry blossoms of this spring. So at the front gate of University of Tokyo. Okay, thank you very much, and I will take any question from you.
thank you very much, Professor Iwatsubo, for an excellent summary of the large-scale projects you've been involved with and continue to be involved with. Yes, I hope you will have a few minutes to stay with us for questions now. Actually, if I also may start with a question, which was that you mentioned several times differences between studies, particularly between J-ADNI and ADNI. And I'm kind of curious, across all of your work, have you found that there are differences that you think go beyond simply the sort of normal differences and variations between studies and actually do indicate differences between Caucasian populations and Japanese populations? You mentioned a couple of things. I just wondered if you could summarize what you think the key, if there are differences, what the key ones are.
Yeah, that's a very, very important point. So there may be several different components. So that is a difference, especially on the ApoE E4 prevalence. Mm-hmm. So that is a real genetic and an ethnic difference. And the other is a selection difference, selection bias. Yeah.
Yeah. Right. Okay, so really the main one was is the ApoE sort of
yeah, considering those as differential points that we have realized that prodromal Alzheimer or MCI due to AD population is very they share similarities, such a high level of similarity. Beyond nation, beyond the country. So that is my very rough impression.
And is it also your impression that that extends to the brain structure and the PET imaging and so forth? Yeah.
Yeah. So as you see now, we have the full set of structural MRI data from the J-ADNI 1 stage. And then Professor Hiroshi Matsuda, who has been the head of imaging center at the NCNP, has been the MRI core PI. So he's a fantastic MRI and PET researcher on Alzheimer with us. But he has just moved to the Tohoku PET center. So most of the MRI structural data left less analyzed. Yeah, but very recently we have collaborated with a couple different international groups, including, for example, the Dr. Westerman's group in Karolinska, and they now have some comparative work on US-ADNI, ABO, and J-ADNI on the pattern of progression of the structure changes, volume loss in AD population.
Right, very interesting. We look forward to finding out more about that. Yeah. So I should open up the questions to my colleagues at OBD, and also Dr. Nakajima has joined us as well. So it's nice to have him here with us. Who we're working with.
Thank you very much for introducing me to the fantastic researchers in UK. Thank you very much.
So any questions? Yes, Jed.
Yeah, that was a fantastic talk. Thank you. I'd like to ask a quick question about the substudy in J-TRC. So you mentioned briefly the tau PET substudy, but I missed what fraction you were aiming for the recruitment there, or what total number. And if I may, a quick second part of that question is, do you have plans for other sub-studies in addition to tau PET, or is it something where there's kind of the potential for proposals for additional sub-studies?
Yes, thank you very much. So basically, we are recruiting the amyloid elevated individuals to the J-TRAC cohort, yeah, and probably 40 or 50% of those individuals will wish to join the preclinical AD drug trials, and the remaining 50 to 60% will stay at the observational longitudinal study. And then we encourage them to join this sub-study. And then our PET researchers have had such long and detailed discussion, and we have chosen the MK60 to 40 as the initial standard PET probe for this study. So that we are anticipating to scan probably 20 or 25 per year for the coming couple of years. So the total number will exceed 100 for 5 years later. And then we also are planning to do some MRI sub-study coupled with amyloid positive population. Yeah, and so this is because we need the structural reference images. Yeah, and for the detailed analysis of tau and also amyloid data. Yeah, but now we don't have such a strong MRI specialty core with us at the J-TRAC. Yeah, and you may know that some other group of researchers here in Japan also originally based in the NCNP, National Center for Neurology Psychiatry. Professor Matsuda's successor, Professor Hanakawa, who is now the head of MRI research in Kyoto University. He has moved from Tokyo to Kyoto. So he has now a very unique functional MRI oriented longitudinal study of Alzheimer, MCI, and Parkinson's. Yeah. So that study is funded by another public funder, the Ministry of Education Science. Yeah. So they are working on a bit more focusing on the MRI, functional MRI aspect. Yeah. So they, we are not sharing the participant, but the basic protocol was formulated by Professor Matsuda. So at the timing of the J-ADNI 2 AMED preclinical study. So we will have such a functional MRI data coming within 2 years. And then they are also planning all the data open to public after they make initial analysis. Yep.
That's very interesting. Thank you.
Great. I propose we have another 10 minutes or so for questions, if that's all right. So who else would like to ask a question? Mario.
Hi, thank you for your great presentation. I have a question about the recent neuropathological investigation have revealed overlapping co-pathologies in AD, including co-aggregates of TDP-43 or alpha-synuclein that could lead to faster progression or typical presentation. Do you think that early or preclinical characterization of AD should go beyond amyloid and tau?
Yeah, that's a great question. So we want to pursue that great program. But talking about our small experience in J-ADNI, so you may know that there are so many fantastic diagnostic neuropathologists in Japan, but recently it's a shame that the ratio of brain autopsy is decreasing. Yeah. But in the J-ADNI 1 population, we had one case who was fully neuropathologically analyzed. So there was a case in the category of mild AD, starting from mild AD, but progressed slightly rapidly. Yeah, and that individual was, participant was from Sendai, Tohoku. And you may remember we had the earthquake disaster 10 years ago. So he survived that earthquake disaster, but he deceased couple months after the earthquake. Yeah, and he had the full multiple pathology, so including amyloid, tau, and algiophilic brain tactile, and hippocampal TDP43 plus numerous Lewy bodies. So we saw that that was one of the reasons why that specific participant progressed relatively rapidly compared to the standard level. So we wanted to have more and more autopsies. But we had to quit the long-term follow-up, because we failed to smoothly transition to the J-ADNI second part. So that was one of our problem. Yeah. But from now on, we may have to use some advanced biomarker or some other specific screening methods. That may be the questionnaire or something to screen for the early stage of alpha-synucleinopathy, focusing on the visceral representation, manifestation of alpha-synuclein pathology, and then to search for some method to efficiently screen the multiple pathologies.
Yeah. Thank you.
Great. Another question from anyone? Michaela, I think, see there, has your hand up.
Hi, thank you very much for your talk. I guess as talking about subtypes of dementia and different types of dementia, do you think current biomarkers are good enough to differentiate between the types? And do you think blood biomarkers are enough specifically, or do we need imaging and more regional information to go deeper into the classification?
Yes. So no, we have been amazed by the rapid progress and advancement of the blood plasma biomarkers, especially the power of p-tau, to detect the increase in tau deposition, together with the background and Alzheimer's amyloid pathology. So now we are now starting to planning to collaborate with some of the p-tau researchers, and then we are actually negotiating with the Eli Lilly headquarters to have the 217 p-tau data from J-TRAC and then original J-ADNI. But as you see, the weak point may be that p-tau alone cannot detect the different types of tauopathies. So my own view is that women definitely need some combination of fine structural and functional imaging modalities to correctly detect and differentially diagnose different types of degenerative dementias.
Thank you.
Great. Another question. Yeah, Ian, I think, slightly ahead of James.
Hello, Professor. Thank you so much for your informative, entertaining talk. I was wondering if you had any personal opinions about the disease mechanism for AD. There is lots of research now that people are wondering whether the amyloid hypothesis is the actual true cause. And as someone who sees an awful lot of different people who have different opinions, I was wondering if you had a personal opinion of where you think might be the disease mechanism coming from.
Yeah, thank you very much. So because I am a half experimental neuropathologist based on the genetics. So genetics means that the pathogenic genes for the pure autosomal dominant familial AD altogether causes amyloid increase or amyloid acceleration. Yeah. So I'm not a very tough Baptist, but I believe that amyloid beta has at least some triggering effect in the very early stage of the Alzheimer's disease. So in the regard, I believe tauopathy in Alzheimer may be secondary tauopathic changes that are stimulated by the amyloid beta. So the real Alzheimer may be that in the advanced stage, all the different pathological mechanisms may start to exert. So the Alzheimer's dementia stage may be very complex, but the upstream may be like those hypothesized by the amyloid theory. Yeah. So that's my personal view.
Thank you so much. So just to clarify, you think that if we caught the amyloid early enough, the amyloid is the cause rather than the symptom early on. Thank you. Thank you so much.
That's one of the approaches. Yeah. Okay.
One last question, maybe. Jamie, did you want to take that one up, that opportunity?
Yeah, sure. Hi, thank you for the talk. And I guess my question was kind of on if you've got any thoughts on the concept of brain health and kind of monitoring, not only just for specific neurodegeneration, but the concept of kind of monitoring from midlife onwards, general metrics for brain health, and how you think that might be useful, if you think it would be.
Yeah, that's a very important point. So now we are focusing on the very early pathological stage of Alzheimer with an increased amyloid level. I believe at that stage we need some preventive therapy focusing on amyloid. But as you mentioned, lifestyle related factors in the midlife may be very, very important. Yeah, and you may know that in Japan we didn't have a finger type multiple lifestyle intervention study, nor detailed epidemiological studies focusing on different lifestyle risks. Yeah, but very recently, the Japanese Ministry of Industry is very much interested in promoting finger-like study funded by the government. So the geriatricians headed by Professor Hide Arai at the Nagoya National Center for Gerontology is conducting a finger-like multiple intervention study called J-MINT, J-MINT. Yeah. And then they are going to have the 2-year intervention results this late autumn. So, and the beauty is that they are also including some imaging study and also the plasma A-beta or beta-181 analysis. So that may be very interesting to see the correlation between the lifestyle intervention and the changes in imaging and plasma biomarkers with that kind of a study. Yeah.
Yeah, great. Thank you. That sounds really interesting, actually. Be great to see.
Wonderful. Thank you. I think we should close the discussion there. But thank you, Professor Iwatsubo, for a comprehensive review of the imaging approaches to dementia in Japan and elsewhere. We hope to contribute to those studies in the future ourselves. So thank you very much.
Yes, thank you. That was my great pleasure too. And I'm very sorry I missed the upcoming AAIC in San Diego, but probably I will, if the COVID pandemic will not worsen anymore. I will be visiting the CTAD meeting that is in San Francisco. Yeah, this December. Yeah.
Yes.
But hopefully that we'll be in touch, and that let's keep in touch, and then talk about the future possibility of different collaboration.
Yes. Thank you very much. I hope. I'm sorry we won't see you in AAIC, but I hope that we will talk about possible future imaging studies together. And yes, there will be some exciting news coming up at meetings like CTAD in the next 6 months, 12 months, with the different drugs coming through.
Okay.
Great.
Thank you.
Thank you very much. Thank you for talking to us today.
Bye. Thank you.
Bye.
Bye.
Bye-bye.